Good job so far. You're well on your way to building really great layouts. However, I do see a problem with almost all of the layouts that we've built so far. The views are right up against the edge of the view group or up against the device. For all of the layouts that we've built in this lesson so far, we could add a little more visual polish to them so that they're more beautiful by adding a little bit more white space. We'll do this using the concepts of padding and margin, which we'll cover in this video. For example, we could add a little more white space here, here, or even at the top so that the views aren't crowded up against the edge of the parent and up against the edge of the device. It's really a design decision though, because sometimes you do want it to go edge to edge, like for the full bleed image effect that I was talking about earlier. But in any case, you can use white space to add a little more breathing room so that the content is a little bit easier to read and scan. I'll show you the effect of adding padding or margin to a view. Let's start with a text view that says hello. If we add 8 dips of padding to the view, then it makes it bigger by 8 dips in every single direction here. If we add a layout margin of 8 dips to the text view, then this is what it would look like. In order to add a margin, you need to put it inside a view group, so that's why I have it in this linear layout here. The linear layout is the one that takes the original text view and pushes it by 8 dips from the left and from the top, and also from the sides as well. So even though you declare padding or margin on the child text view, the padding gets handled by the text view itself, whereas the margin gets handled by the parent view group. If you run both of these on a real device, and you didn't have a background for the text view, then technically both would look the same. The text would start 8 dips over from the left and 8 dips below the top of the device. However, if you do have a background color for the text view, then the user would be able to see that the text view is this big, whereas on the other device, the text view would only be this big. Here's the code for displaying padding on a view. On the TextView XML element, you would declare a new attribute that says Android:padding equals, and then 8 dips in quotation marks. You can choose whatever size you want for the padding, as long as it's a dip value. When we specify 8 dips of padding, it adds 8 dips to the left, top, bottom, and right edges of the text view. Instead of using the general Android padding attribute, you can also split it out to left, right, top, or bottom. Essentially, these 4 lines of code do the same thing as this one line. However, these fine-grained controls allow you to have different padding values for left or right, or top or bottom. You don't have to have an equal padding value for all 4 directions. The default value for padding is 0. So if you specify left, right, and top padding, but not bottom, then that will be 0 dips of bottom padding. To specify margin, you add an attribute again to the text view. The name of the attribute is Android:layout_margin. You can set it equal to, for example, 8 dips. This moves the child text view 8 dips away from the parent on all edges. If there was another child text view at the top here, then having a margin would push this text view 8 dips below that first text view. You can think of having a margin as having a little force field around this view. No other view can enter this 8-dip region around it. Or you can also split out layout margin into each of the 4 directions. Layout margin left, layout margin right, top, and bottom. If you don't specify any of these values, then it will default to 0. To remember that the view group is the one that positions these children based on margin, you can look at the attributes. They all start with layout_ for margin. That way you know that the view group is the one who's handling the positioning of these views. Padding and margin can apply to all views. Let's put the attributes we just learned about into practice. Here I have 3 text views in a linear layout. They're all squished up against the left edge of the screen, so I want to add a little more space. Let's start by trying to add some margin. Cool, now there's more space around this text view. I'll do the same for the other 2 text views. Interesting, so this is 16 dips up here, but this is actually 32 dips because it's getting 8 dips of bottom margin from the first text view and 8 dips of top margin from the second text view. If we want the spacing to be consistent, so it's always 16 dips in between each view, then we have to change the margin here. I can break it out into individual margin values. With this code, I have a left margin of 16 dips and a top margin of 16 dips. There's no bottom margin from this first text view, so this space in between is now correct at 16 dips. The same will go for the last text view. Cool, now all the vertical spacing is equal. Earlier when I said we're adding white spaces to the edges of these views, technically that space is transparent. You can see through it to what's behind it. In this case, we have a gray background on the view group. Now the layout would look the same on the device, whether we use margin or padding, because in this case we have no background color on the text view. Let's add it and see where the bounds of each view are. Okay, now there's a background color on this first text view. When we added the left and top margin, we see that the view group just pushes the text view over by 8 and down by 8. We can change this to padding, and now we see that the text view is larger and takes up that 8 dips of space on the left and top. So visually, things would look different on the device whether you have padding or margin if there is a background color on this text view. We can do the same for the other views so you see that as well. Adding padding and margin values isn't just restricted to these children views, you can also add it on the view group. If I add a padding value for the linear layout, then you can see that it shifts the views over by 16 dips in all directions. I mentioned that you could set any value for padding or margin. But how do you know which value to pick? Well, the material design guidelines recommend that you use increments of 8 dips. This is a little bit more advanced knowledge, but essentially we want our components to line up on the screen along this 8-dip square grid. Now the squares don't actually show up on the screen, but if you want to position text here, you might want to move it over like 2 squares to the left. 2 squares on this grid would equal 16 dips. On this email screen, all the icons are lined up to this line. They're positioned 16 dips over from the left edge of this screen. And all this text here is positioned 72 dips over from the left edge of this screen. So you can kind of imagine that the content is starting to follow certain lines here. Here's another way to visualize it. In this screenshot from the Google I/O app, we have the content lined up to this 16 dip line, as well as this 72 dip line. It's essentially 72 dips over from the left edge of the screen. And on this edge, the content stops 16 dips before the right edge of the screen. On the tablet, you have more screen real estate, so you can have a little more padding. You can be 24 dips over from the left edge of the screen, and so on for the other values. The reason we recommend these values is to make your content easier to read. For example, if this title was shifted over by a couple pixels and this subtext was shifted over to the right by a couple pixels, there would be a jagged edge here, and it would distract the user from actually reading your actual content. So by lining everything up, it makes your app easier to read and use. Here are a couple of real-life examples of using padding and margin. In this Google Calendar app screenshot, we see some text here that's shifted over by a little bit here. There's also a little bit of space between these calendar events. If we implement it using padding, then this background image would probably extend into that blank space. Instead, if we use margin, then it adds a little buffer zone around the view, so it's probably margin. Here's another screenshot of a detail page for a calendar event. There's a lot of text here, and there seems to be larger gaps than others. We can create those larger gaps by adding padding. To add this gap here, you could either add bottom padding to this text view, or you could add top padding to this view. Either way would work, or you could even implement it using layout margin. You really can't tell the difference between using layout margin or padding in this case because the background of the text views is transparent. Now it's your turn to practice with setting different padding and margin values. We've provided some initial code for you to get started using the link below. Once you're comfortable with padding and margin values, go ahead and try to build out this layout. By the way, this text is located 16 dips from the edges here, but it's only 8 dips in between the two text views. When you're done, check this box.